In the previous episodes, we've seen how we can validate and create food records in our database, but currently there is no connection between the created food items and the authenticated user. In this video, we'll create a relationship such that each user can have their own list of foods they can pick from when tracking their daily calories. Registering users is something we'll tackle later in the series, but one solution for now is to manually insert a new user record using the database seeder class. But before we start, let's look at the user's migration file, so we know what fields we need to fill up when creating a new user. So the required fields are name, email, and password. All the other ones can be null. Now if we go to the database seeder class, this class is ran whenever we call the PHP artisan db seed command, and it helps us create test data for our application. You can either delegate to other seeder classes like this, so you can call a user seeder class, or you can just create the user directly. So we'll do that and use the user class and then create, and then we need to pass in the required fields, which are name, let's say John, email, and password. The password needs to be hashed, and for hashing we can use bcrypt. This is the bcrypt function that will use the bcrypt algorithm to create a hash of the string we're passing in. And let's make sure we also have at least one food record. So food equals food create, and we pass in all the food columns. Now let's run the seeder and see if our database is populated. So PHP artisan db and seed. Okay, we get a nice confirmation message. And if we go to our database and refresh the foods table and the users table, we now have two records we can play with. The next step is to create a relationship between the user and the food items, such that we know to which user a food item belongs to. We can do that by adding a user relationship method on the food model. So if we open up the food model, we can add in a new method called user that will return a belongs to relationship. We can do this. In order for the belongs to relationship to work, we need a user ID column on the foods table so we can use it to connect food records to a specific user in the users table. Let's add that user ID column to our food migration class. ID columns in Laravel are big integers that auto-increment, so we'll need our user ID to also be an unsigned big integer. ID. And now we should run the migrations again and also the seeder, and we can do that with PHP artisan migrate fresh, because we want to dump the previous tables and use the new migrations or the updated migrations. And to seed the class we can use -- seed, and we get an error that says field user ID doesn't have a default value. So this user ID field is now required when you are creating a food. we go to our database header, we can provide it here and give it the value of this user right here. We'll do user and access its ID. And if we run the command again, it surely works. Let's take a look in our database and see the updated columns. And here we have our user ID. To make sure that our relationship works, we can use the equivalent of console log in Laravel, which is die&dump dd, and call the user relationship. And now if we run the same command, we should see our user in the console. And here it is, the user model with all its attributes and whatnot. The only reason we added the user ID column in the foods table is so that each user has its own list of foods. But as it is right now, only the food model knows about the user. There's no relationship that can give us the food records of a specific user. What we need is called the hasMany relationship, and it basically backtracks on the belongs to relationship. We now use the user ID column in the foods table to grab the foods of a user, not the other way around. Okay, so let's add it. Let's go to the user model and create a new foods method. That will return a hasMany relationship. And let's make sure we import this class. And now to test it, we can do the same we did with the user relationship, which is die&dump user, and we'll now call the foods relationship. Let's run the migration and seed again. And you see that we now have a collection of foods of which we have milk. If we create another food item, let's do it like so. Come on. And say this is bread. And run the migration and seed again. You'll see that we now have 2 items in our food list. Now that we have the foods and user relationships in place, it's time to make use of them in our API endpoints. But since authentication is something I plan on doing later, I will show you a quick workaround we can use to trick the system into thinking there is a real user authenticated. If we go to the api.php file, before the execution process hits all these route files, we can authenticate a user using the auth login method. So auth login, and this method expects a user as a parameter. And we'll just grab the first user from the database using the user first method. And now, basically, whenever the execution point gets past this auth login method, we have a logged in user. If we go to our foods controller, we can die&dump the authenticated user by calling request of user. And this will give us the currently authenticated user. If we call this endpoint, we also need to start the server. Do it again and hit the preview tab. So this is our currently authenticated user. Okay, so let's go back to our controller and see how we can use this user. So the first thing we're going to do is actually return the foods of the currently logged in user. Right now we are querying all the food records in our database, and we'll only need the logged in user's foods. So we'll do this and paginate. Go back and call the request. We get the foods of this user. But to make sure this works, we should create 2 users and 2 foods. So we'll say user A and food A. And here we'll have user B and food B. This and food B. This one will have bread, which is okay. Oh, user B. And let's run the seeder again. I'm gonna open up a new terminal. Okay, and now if we go to the database, we should have 2 users, which we do, and 2 different foods for each of the users. And now if we call the endpoint, we'll see that we only get the food item for the user with an ID of 1. Okay, so this part works. The next part is when we store a food, we should also include the user ID of the currently logged in user. Because now if we go to the storing endpoint, we'll see that it's not working because one, we're not sending all the fields, and the selected unit of measure is invalid. But now it will fail because we're not setting a user ID. So if we go back, we can grab the user ID from the request by doing user ID equals request, grab the current authenticated user and its ID. If we go back now, this will work and return the newly created food item. To make sure that works, we can call the index method and see that we now have only 1 record. What? Oh, we have the pagination of 1, I think. Yeah. We need to remove this. And we now have both foods. Okay, let's see what's next. So we have the create method, and here on the update, we also need to do the same. So we only want to allow the current user to update its own foods. So we'll do request user foods find or fail. So now if we go to our postman and make sure we send in all the fields, we should try to update the food with the ID of 2, and this will return a 404 because this food doesn't belong to the currently authenticated user. And we should do the same for the destroy method so that other users don't delete other people's food. User foods, and if we try to delete the food with an ID of 2, we will get a 404, which is what we want. Let's see if there is anything else. Yeah, we could also do it here. So other people keep their noses outside of other people's foods. So if we try to do a show for this route, which is this one, we should also get a 404, which we do. Okay, let's do a final check. So we have the user here. We set it here, okay. Yep. that's pretty much it. See you next time.